we at Melbourne Data Analytics Platform have been going for about 12 months, and we believe we're well positioned to be able to, I guess, not only tackle crises, but potentially predict them and deal with them as they come to hand. Today, I'll give you a bit of an overview of what Melbourne Data Analytics Platform is, and along with the team, they'll talk about the kind of expertise and skills that the team have, but then also we'll give you some examples of some case studies and collaborations, projects that we've been working on. Not all directly relevant to crises, but certainly to give you a flavour of the kind of things that we can do in response to major issues that come up around the world. So MDAP, or Melbourne Data Analytics Platform, are a team of academic specialists working to enable data-intensive research across the disciplines at the University of Melbourne. And we were formed as the workforce component of the Petascale Campus Initiative, or PCI, which is a 5-year plan to accelerate the university's capacity for data-intensive research. The PCI is structured to support an academic-led vision. And really, its major aim was to embed a process of continual improvement through consolidation, development and resourcing for both our digital science infrastructure and the workforce that will help us maximise our use of that infrastructure. So that's why infrastructure is really one of the main investments from PCI, and but it's really within an academic framework, and we at MDAP are the workforce component of that initiative. To give you a broader view of the landscape here, this is I guess a beehive diagram, really outlining the 23 platforms across the University of Melbourne within the research infrastructure landscape. Now, the majority of these platforms are supported through the Melbourne Collaborative Research Infrastructure Program, or MCRIP, and many are equipment or facility-based platforms, maybe traditional kind of platforms when you think of those in a university setting. But there are also many, there are a handful similar to MDAP who are people-based platforms with more of a collaborative focus. And you can see from this slide, the figures in the corner here, that's a significant investment made by the university. A large number of people within that workforce that are supported across these platforms. But it doesn't really capture the complexity of the digital research landscape at the University of Melbourne. So we at MDAP, we're really fortunate to be able to be supported not only centrally through Chancellery, but also through the 10 academic divisions or faculties within the university, which is quite different to the PCI. So the PCI is fully centrally funded by Chancellery, where we're funded 50-50 Chancellery and then academic divisions. And so we have three main areas of focus. So firstly, collaboration. So we are an academic unit with a team of highly skilled research data specialists and data stewards working across the entire research life cycle, as distinct from a research service provider. And MDAP's bottom-up approach allows us to collaborate and engage directly with researchers and research groups, which is a little bit different to the top-down approach and strategic direction of the PCI. Now, our team's experience and background covers a wide range of disciplines and fields, but we are experts in digital methods and are uniquely positioned to understand the language of computer scientists, data specialists, data stewards, and even those researchers who don't have data-intensive backgrounds. And whilst we were ultimately evaluated on similar metrics to those imposed on traditional teaching and research academics, we also value non-traditional and qualitative research outputs. So we're currently quite a large team. So we have 13 research data specialists and 4 research data stewards. There's myself as the platform manager and Professor Andrew Turpin as the academic lead. We're also lucky enough to have part-time support from a marketing and comms specialist, Joe. Where is Joe here? Let's see her face. These are all the, sorry, just here. I knew I'd find her eventually, sorry. And a business analyst, Ursula. So our team does come from a wide variety of academic domains and backgrounds, many different computational disciplines, and with an amazing breadth of skills. Now, the great value that MDAP brings to research collaboration in particular is the collective experience and expertise. I'm going to throw over to Ma now, who will talk you through some of those roles, particularly the research data specialists to start with. Thanks, Ma.
Thank you, Andrew. So the next slide shows the main 4 pillars of engagement that we have. So most of the time we spend working on research projects with other University of Melbourne researchers, and I'll give some more details about what that means in a little bit. But we can also provide smaller consultancies, and these can be mostly focused on best practices or advice in writing grants, or even designing research practices. So more of a smaller one-off interactions as well. But while we are doing these two, we're in a very unique position to be able to advocate for the needs of the researchers that we work with, because we're working with them directly on a project, and we can feed all of the needs that come up during the research project itself back up to the Petascale Campus Initiative that Andrew mentioned at the beginning, and through them to the senior leadership at the university. And our 4th other very important goal is to build a community of like-minded researchers from all of the disciplines in the university, and connect people with complementary skills and interests within the university. And the idea here is we really want to help break down the silos in which each discipline is kind of working on something by themselves, and they're actually doing things that are quite similar to what another discipline is doing, but they don't have many channels to talk to each other and to share that knowledge and to build up on these practices. So we really want to promote collaborative research and promote knowledge sharing. So if we go to the next slide, please, Andrew. This shows the main modes of interaction that we have. So when I spoke about working collaboratively in research projects, I'm referring to these collaborations. This is the formal way of engaging with MDAPers. So we call for expressions of interest 2 times per year for collaborative projects lasting between 3 to 6 months. And we choose the expressions of interest that are adequate for our expertise and for our mission. But then these are selected by a very high level academics in the university based on their strategic value and based on merit. So it's an independent committee that is making these decisions of choosing which ones of these we're going to take on and tackle for the next 3 to 6 months. The other way of interacting with us is more informal, in the form of, we call them projects. So these are always open as far as the team has the capacity to do it, and this includes the consultancy and advice. And all researchers have to do to engage with us in this form is email us to the email address that's there on the screen, and then we can work something out. So Andrew, if you go to the next slide, please. I want to talk a little bit about what specifically is the role of the research data specialist. So me as a research data specialist, how do I engage with other researchers in the university? Well, normally we'd work with a domain expert on a certain project that the domain expert is wanting some advice with or help with in order to really exploit the possibilities to do with their data. So while we as research data specialists are learning from this domain expert about their specific domain of work, we hope that they're also learning from us things to do with both technical tools, through collaboration, we introduce the domain expert to some cool state-of-the-art digital techniques. So, for example, with cloud and high-performance computing, we work very closely with research computing services. In fact, I'm an MDAPper, but I sit with research computing services half day every week. So we're completely up to date on what resources are available and what's the best way to use them. And also in terms of novel data analytics, of course, our collaborations all revolve around implementing novel techniques to data and programs in different areas. But we also have a very close working relationship with the Melbourne Center for Data Science, whose objective is developing novel methodologies to deal with problems that don't yet exist. So while we focus more on using existing techniques on problems, they focus more on developing novel techniques. So we're all interconnected with different organizations within the university, and we can really help make the most of what the university can offer. So if we go to the next slide, please, Andrew. I'll talk to you a little bit about the responsibilities of us as data specialists. So we see ourselves as being in a very unique position to be able to introduce researchers to new technology in the form of cloud or high performance computing. We have experts in visualization and natural language processing and image and video processing. Because we have such a broad range of people coming from all disciplines, we have a range of expertise in different software languages and packages, version control, data wrangling, machine learning, bioinformatics, virtual and augmented reality, you name it. And so the idea is that we'd work with researchers on projects in a very collaborative mode where we expect to be able to provide intellectual input into the research project, write new research software in collaboration, design new algorithms, contribute to data analysis pipelines, and automate error-prone processes. And because we're participating in the whole research process, we expect also that we will be co-authoring research papers and contributing to other research outcomes in the form of open software or other non-traditional modes. So I'll throw that's for data specialists, and I'll throw over to Crystal now to talk to you about data stewards before we move on to some example projects that we've worked on in the last year.
Great, thanks very much, Mark. Can you hear me okay? Brilliant, thank you. Yeah, so thanks very much for that, Mark. So for the members of the audience, I mean, you've probably heard terms like research data scientist thrown around before. You've probably got a bit of an idea about what that's all about. And if you don't, well, Mark just gave an excellent overview of what a research data specialist does in MDAP. But what exactly is a research data steward? So let me start by saying that this idea of research data stewardship, it's a developing capacity internationally. So there isn't yet a widely agreed upon definition. So what I'm going to do today is tell you about what a research data steward is at the Melbourne Data Analytics Platform. So as Mar just explained, above all, we collaborate. So every one of our activities is focused on and it's shaped by our role as academic researchers participating in collaborations. We're fully embedded within collaborations, both in our capacity as a research data steward and as a domain expert. By being solely research focused in this way, we're able to work together with our collaborators to produce high impact research outputs and to co-construct novel approaches to data-driven research. So each MDAP research data steward is a domain expert. This means we have a track record of research experience in specific domains, from archaeology to health sciences to music to conservation. So we have quite a wide variety of skills. But why does this matter? Well, it matters because it allows us to understand a range of different research areas and research data. There's no one size fits all when it comes to data intensive research. And so there's no one size fits all when it comes to research data stewardship. We need to be versatile and agile and responsive. And our diversity of domain expertise allows us to do this. So one of the key aims as research data stewards is to enhance the intrinsic value of research data. So we all know that data is valuable, and it's valuable because it's a record. So what data records depends on the kind of research or the kind of activity that it is recording. But usually, data is a record of an action or a thing at a particular point in time that can't be reproduced. So does this mean it is infallible, objective, a complete record of that action or thing? Well, not really. There are so many different kinds and sources of data, but the most important thing to remember is context counts, always. As a research data steward, a big part of my job is to understand and untangle this context and to think about how context and data interrelate. This is a significant aspect of adding value to any data-driven research project. So all that sounds a bit abstract, so let me give you an example about why context is so important. In 1998, NASA launched the Mars Climate Orbiter. It cost about $327 million. 10 months after its launch, the orbiter reached Mars. On September 23, 1999, it began its descent. As expected, the orbiter went out of radio communication with Earth for about 20 minutes or so while it performed a series of space maneuvers. The team on Earth obviously waited anxiously for this very expensive orbiter to re-establish radio communication. But it never came. And after 3 days of radio silence, the mission was declared a loss. The orbiter has never been found. So what happened? How do you lose $300 million worth of equipment? Well, it was later discovered that one party working on the mission was calculating the required thruster force for descent in a unit called pound-for-second, while another party was doing the exact same calculations, but in a different unit called newton-seconds. The absence of this one small bit of context, the unit of calculation, cost over $300 million and countless person hours. And that's why context counts. So in addition to adding value, we also work to ensure that research data integrity, research data integrity into the future by promoting reproducibility. So this means a few things. First, we put data in a place where it can be found, either by the researcher or by someone else. It's not always as simple as it sounds though. There's no one publishing platform for data like we have for books, for example. So data can sometimes become slippery and it can easily disappear without a trace. And when you think about the amount of time and money that goes into data gathering, you can see how this might be a problem. Second, we document the process by which data was captured. This is a kind of metadata being information about the data. To fully understand data, especially when you're using someone else's data, you need to know how it was captured and under what conditions it was gathered. And finally, we think about how we can make different data sets talk to each other. That is, this might be something like file format. So to use a bit of a crude example, just as you can't fit a round peg into a square hole, you can't open a Word document in Excel. This is what we mean by making data talk to each other. We call this interoperability, and interoperability is important to optimize data. You might have 6 different kinds of data sets which are building a narrative around a particular crisis, for example. But if those data sets can't be combined, if they aren't interoperable, then you can't construct any narrative. So while we do all this, we're also working to establish an emerging international specialization. So as I said before, the field of research data stewardship is developing capacity internationally. But MDAP is really at the forefront of applied research data stewardship in an academic context. As far as we know, there's no one doing research data stewardship quite like us. That is, considering it as a research-driven academic career path. So why does that matter? Because it means we can walk between worlds. We speak the language of data-intensive research communities, but we also speak the language of our domain expertise. This means we can enable our domain-specific colleagues to participate in data-driven research, while at the same time reconceptualizing what data-driven research is in the first place. Shortly, I'll give you an example of what this looks like, but first let's drill down into the specific responsibilities of a research data steward in MDAP. Andrew, if you could go to the next slide, please. Great, thank you. So MDAP employs 4 research data stewards, and we can be involved in research at all stages of its life cycle, from the conception of research questions to the analysis and dissemination of results. We build capacity in the areas of research data management, and we capitalize on research data outputs. We aim to develop communities around data practices across the disciplines. We reconceptualize and we adapt data-intensive methodologies to certain disciplines, and we co-author papers about that. We manage relationships by bringing researchers who might be data adjacent into the data-intensive sphere and connecting researchers and services with each other. And we also upskill, not only in tools, but also in practice, such as embedding reusable data principles into researchers and research projects. And the list goes on. No 2 days are ever alike. So let's see how we apply these skills in our networks. So next slide, please, Andrew. Thank you. Okay, so as you can see on the left, Every MDAPer has a unique combination of academic domain specialty, organisational skill sets, and computational expertise. This comes in very handy when you're walking between different research worlds. So as an example, at MDAP, we currently have a collaboration with researchers from Fine Arts and Music, the Graduate School of Education, the Melbourne Centre for the Study of Higher Education, the Social and Cultural Informatics Platform, and Student and Scholarly Services, as well as engaging regularly with colleagues from learning environments. So each of these groups shared a common interest in how education and creative industry sectors were showing resilience in the face of COVID-19. But they didn't necessarily have a shared or common methodology, or a shared or common approach to data-driven research, or a shared set of languages to describe the methods and the tools being utilised. Myself and a colleague in MDAP, Emily, have been working in this collaboration to prototype a data strategy for such a heavily interdisciplinary but data-driven research group. We've drawn heavily on our skills of walking in the world of data-intensive research and all the methodological considerations and language requirements to communicate that come along with being in this space. But we've at the same time drawn on our domain expertise to shape the research and to contribute to the cultivation of its direction. This is a fundamental strength of MDAP, and it's afforded to us because we're expected to utilise all three of our skill sets, domain, computational, and organisational, in our day-to-day research activities. The other added benefit is that we can engage with university services and provide researcher-specific perspectives. So as an example, one service with which we very regularly collaborate with is scholarly services. So scholarly services have a set of stewardship capabilities which play an essential role in the uplift of data stewardship within the university. As MDAP research data stewards, we take a very micro-level approach. We're embedded in specific research projects with very specific researchers to achieve specific research outcomes. Scholarly services is able to work from the other end of the spectrum. They take a more macro-level approach. Thus, by collaborating with scholarly services, MDAP research data stewards are able to contribute case studies and on-the-ground examples to develop high-level guidelines and protocols. And this interconnectedness is a real strength of our partnerships and a strength of MDAP in general. So at this point, I'm going to hand over to my colleague Noel, who's going to provide some examples of case studies.
Hi, I think you should all be able to hear me and see me. So I'm just going to give an example of a case study involving the Faculty of Vet Science and Agriculture. This is looking at the discovering dark matter in the genomes of parasites. It really comes down to needing to understand the population structure of these parasites. And as part of this workflow, we need to annotate or genotype the entire each of these parasites, which requires whole genome assemblies, and these are non-model organisms, so the assembly is difficult, and additionally finding the right genome to actually reference against to make your variant calls can be hard and long. So while we weren't doing the exact analyses, we're porting an existing pipeline that identified the variants across each of the different samples into a high-performance computing environment, such as Spartan at the University of Melbourne. You move to the next slide, please, Andrew. So this is the overall pipeline, and it's quite a large and complex pipeline. And the overall pipeline involves quite a number of different languages, including Perl, R, and Bash scripts. It wasn't designed for a high-performance computing pipeline when it was written, and what we've now done is ported this in using workflow description language, which allows us to run this in a highly parallelized environment such as Spartan or HPC. The overall runtime has been significantly reduced and allows the actual collaborator to do the analyses that they're looking to do in more timely fashion. And it's particularly important when they say there's a sudden outbreak of an agricultural pest or parasite, and they need to understand the actual population structure to decide which is the best form of treatment. So next slide, please. And I think we're doing over to Simon for another example.
Thanks, Noel. Hopefully everyone can see and hear me. So my name is Simon Much. I'm one of the senior research data specialists in MDAP, and kind of going along with the theme of science in time of crises, I'm going to talk a little bit about collaboration that we've done with some researchers at the Australian-German Climate and Energy College at the university, led by Professor Malte Meinhausen. And so what these researchers wanted to do was to get some help from us to make predictions to contribute towards decision making for how we can plan and adapt for climate change. And also recognizing the importance of the data that the researchers are using and generating, they also wanted to be able to produce an online resource to make it available for other researchers and for the public more widely. So if you can go to the next slide, please. Thanks. And so before I go any further, I should just make the important disclaimer that I'm not a climate research expert. I'm an astronomer by training, but actually many of the tools and techniques that we use are quite closely related, it turns out. So the climate system is extremely complex, as I'm sure you can imagine, and there's lots of different variables and physical mechanisms at play. And so doing a really detailed theoretical climate model is very computationally expensive, needs large supercomputers to run, and takes many days, weeks, even months in some cases. However, the researchers we're working with, though, they actually use a different kind of model called MAGIC, which stands for the Model of the Assessment of Greenhouse Gas-Induced Climate Change. And this model is much simpler and cheaper. And it does this by, instead of doing detailed predictions for individual areas of the planet and different heights in the atmosphere, for example, it really just does predictions for the climate averaged over the entire northern or southern hemisphere. What's really nice, though, is the simplicity of this model means it can be run many tens or hundreds of thousands of times. And that means it can be calibrated to reproduce historical records and the predictions of these more expensive models, so that we can evolve MAGIC forward and make predictions and explore the full range of possible climate scenarios. So for example, what we can do is we can take different emission scenarios for the future, and we can run that through MAGIC and translate that into requirements on potential social and economic policies. So if you can move forward, please, Andrew. Great, thanks. And so this is an example plot in the bottom right here, taken from an intergovernmental panel on climate change special report, which shows possible global warming scenarios where the ranges for what the warming may end up being in the future depends on how we act to curtail emissions now. And these predictions were made using MAGIC and other similar models. So it's a really powerful tool for governments and policymakers. An important part of our collaboration with the researchers was to bring our computational skills and our research background to help them develop software and tools that they could use to rapidly explore the free parameter space of the model and produce robust predictions such as these at a faster rate. Next slide, please, Andrew. Thanks. So as I said previously, MAGIC needs to be compared with the results of more computationally expensive and detailed climate models. And so to do this, the researchers make use of a large database of simulation results called the Climate Model Intercomparison Project, or CMIP-6 data. And that continually brings together the latest results of many of the different models which have been designed for exploring detailed aspects of the climate system. So it's a huge data set. It's many petabytes, continuously growing. So a petabyte is around about 1,000 gigabytes. And the researchers need to download the data, align it all, account for differences between the different data sets, and then average them to produce temperatures and different gases and things over the two hemispheres. So it's a huge data processing task. And as part of our collaboration in MDAP, we helped the researchers to obtain and to set up the necessary storage and computing infrastructure they needed for this task. And recognizing the usefulness and importance of the resulting reduced data sets, the researchers also wanted to produce a website and accompanying API where researchers, policymakers, and the public could go to grab the data and look at it for themselves. If you can move forward, please, Andrew. Thanks. So in close collaboration with the Faculty of Science IT group, we helped the researchers to produce a website that does just that. So you can log on and you can feel free to go and have a look at the website yourself and have a look at the data, cmip6.science.unimelb.edu.au. You can go on there and you can query all the different reduced data sets that the researchers have looked at and brought together. And then if you can move forward, please, Andrew. Thanks. And then you can plot those all up as well. You can download the data, and if you want to use this data in your own code, we've also provided an API for anyone as well. So that's everything I have. Thanks very much.
Good afternoon, everyone. I'm Usha, a research data specialist at MDAP. One of my most favorite projects is being able to deploy machine learning for predicting airborne pollen during the hay fever season.
Hi,
Melbourne pollen from the School of Biosciences, led by APROF Ed Newbegin, Dr. Edna Punani, Dr. Jeremy Silva have been in the field of pollen prediction for over 30 years. The system is a key input stream for the Victorian thunderstorm asthma prediction by the Bureau of Meteorology and the DHHS. We are not sure what exactly makes it so, but Australia is one of the highest allergy rates in the world. 1 in 9 Australians suffer from asthma and 1 in 7 from hay fever. Melbourne has even been termed the allergy capital of the world. So while there has been some research in the Northern Hemisphere around this, our unique flora, landscape, weather conditions, etc., make the local research vital to be able to piece together what makes it such a phenomena, such a severe phenomena out here. If you could move, please. Thank you. A high pollen event is a rare event detection. False negatives can be really devastating with severe implications for public safety. So being able to build an accurate, explainable, and fast prediction model is simultaneously very challenging and also a very rewarding feeling to get right. Now, since they're very good at what they do, we sat down with them to discuss what it was that we could bring to the table that would be of value to them. And it was machine learning to complement their existing statistical forecasting system. Well, why machine learning? Because it can very easily identify trends and patterns without explicit instructions. A very minimal human intervention, just set it up and it'll run. There's continuous improvement. If you retrain your model daily, it'll learn by itself once exposed to new data and you don't have to do anything more. It can handle very large multivariate data sets at the same speed. And the proof of concept that we built showed some very promising results. Hopefully, we are deploying it in Victoria for the 2020 season as a part of the forecasting suite. Next, please. Our next case study comes from the Faculty of Veterinary and Agricultural Sciences, Dr. Shuki Raymond Lamb and Baba Pan of the Soil Group. In our changing world, precision agriculture has become vital to food security and the well-being of a whole nation. It's an area that's quite ripe for innovation. It really has the potential to transform the lives of several millions across the world. And it is also a field that has just begun waking up to potential cross-disciplinary efforts, such as from image processing, big data, machine learning, and all these buzzwords that are going around. These buzzwords have not touched this field yet. Raymond and Baba are experts in their field. Please, if you could move the slides. Thank you. Raymond and Baba are experts in their fields. They analyze the soil nitrogen loss pathways in an effort to minimize the loss and maximize the soil productivity by developing the right agricultural processes for it. This was a mutual learning opportunity where we found out what the need of the day was in this very practical field. And they were able to figure out if machine learning could be suitably employed in their research, and if so, how best. Indeed, fields such as these have input data that's in a form that most non-Earth-side data scientists are very familiar with. Satellite grid imagery, greenery, vegetation indices, land use grid imagery, weather imagery, things like that are very difficult for non-Earth-side background people to work with. But once you know how to do this and to be able to decipher how to deal with it and draw information out of it, immediately machine learning can unlock a vast and almost limitless field of possibilities for what can be done with all this data. So it was a very good project to be on and finish for them. With that, I'll hand you back to Andrew. Thank you.
Thanks so much, Usha, and thank you to Ma, Crystal, Noel, and Simon as well for that. I think it's a quite comprehensive kind of overview of what we do at MDAP, what the various roles are of our staff, and some great case studies across the sciences that we're engaging in at the moment, but there's many more as well. You can see what other projects, collaborations we're working on currently at our website here on the screen. If you're wanting any more information, you can also email us at that MDAP-info inbox and or follow us on Twitter.